DevOps. As you might have seen on the program, the conferences will be in English. We start with Thierry Carrez from the Open Infrastructure Foundation for the first talk. For 20 minutes, we have another talk about SlapOS, 20 minutes, and then a break, and then other talks. So you have a break in 40 minutes. Thank you.
Hello everyone, my name is Thierry Carrez. I'm the Vice President of Engineering for the Open Infrastructure Foundation, which you might know better under its older name, the OpenStack Foundation. And I'm also a Director and Officer at the Open Source Initiative, the body that maintains the open source definition and the list of open source licenses. And today I want to talk to you about open infrastructure, the idea of providing computing, storage, and networking infrastructure using open source solutions. So let's dive into this infrastructure concept. If you look at the history of computing, applications are traditionally represented like this, with users on one side accessing applications on the other. But the way you deliver those applications has been evolving. 20 years ago, you would procure some physical hardware, and as an application deployer, you would install an operating system, install your dependencies, install your applications directly on top of that. But then, since then, we started adding more and more abstractions, more layers. The first layer we added was hardware virtualization, abstracting the server your application is running on from the physical hardware that runs the server. Then we added cloud APIs to allow you to programmatically access those virtualized resources. So at that point, you have programmable infrastructure on one side and cloud-native applications being deployed on top of that. More recently, we added a new layer, the application deployment APIs layer, which is basically what Kubernetes provides. That's higher level primitives that you can use to deploy complex applications on top of this programmable infrastructure. So you're getting the idea here. There is this growing role, separate role of providing infrastructure for application deployers to deploy on. And those are actually two separate roles in most companies. And this infrastructure providers population is the people we care about when we talk about open infrastructure, giving that population open source solutions for providing infrastructure. Because providing infrastructure has traditionally been the realm of proprietary hardware and software. But there are key benefits in using open source software for providing infrastructure. You have the classical open source technical benefits for users, like availability, the fact that there is no barrier to trying out the software with all of its functionality, the fact that there is no friction going from that experimentation to production. There is sustainability, the fact that the software remains available even if the businesses supporting it change their mind or go bankrupt. There is transparency and self-service, being able to look under the hood into the source code and understand by yourself how the software works or why it behaves the way it does. And you have the ability to patch it when it fails. And finally, for openly developed projects, you also have the ability to engage in the community producing the software and influence its future direction by contributing directly to it. Those are the very traditional open source user benefits. But there are also a bunch of specific benefits specifically to using open source for providing infrastructure, what we call open infrastructure. So you can control cost. The fact that you don't have per seat licensing means you can keep costs under control for your private infrastructure. It will also enable you to have a more hybrid usage, use private infrastructure powered by open infrastructure for your base activities, but burst to the public cloud for all the exceptional needs, all the variants. You can also unlock specific capabilities, like deploy very specific hardware, accelerator card, atomic clocks that you won't find on the public offering. And you will also guarantee compliance with local regulations, thanks to your access to the source code and the fact that you directly run it. Those are clear business intrinsic benefits to using open source for providing infrastructure. But there are also a bunch of specific extrinsic social benefits to that. By using open infrastructure, you enable interoperability between deployments using the same technology. That fosters a very healthy ecosystem of companies that are using the same APIs. Open infrastructure providing technology, open infrastructure also makes infrastructure technology available to everyone, regardless of geographical location. And this availability allows everyone to innovate without asking for permission, maximizing innovation. And finally, collaborating on the same source code avoids wasting time and energy reinventing separate wheels in multiple competing companies. This is really why open infrastructure really matters in today's world, very competitive and very generating a lot of waste. So looking at the history of open infrastructure so far, like I said, providing infrastructure used to be the realm of proprietary software. If you go back to 2010, there were only two players in town. You had VMware, which had owned the private infrastructure space for 10 years, and you had AWS, which was the only public cloud available for the last 5 years. And that's when OpenStack was started. And it changed the game. It created the concept of open infrastructure by proposing an open source solution to build a pure infrastructure as a service cloud. It was from day zero designed to accommodate the need of private clouds as represented by the involvement of NASA, and the needs of public clouds with the involvement of Rackspace. And OpenStack also introduced the concept of the four opens: open source, but also open development, open design, open community. And it's been a huge success, and we'll go back to that later. That success was soon emulated by others, including Kubernetes, following the same open development model. Kubernetes standardized the application deployment layer, which gave birth to the cloud-native movement. But cloud-native assumes that there is a cloud underneath. This is why Kubernetes works so well with OpenStack, in combination with OpenStack, providing the lower-level infrastructure that Kubernetes needs. And Kubernetes was a huge success too, but open infrastructure is not limited to those two projects. There are a lot of other ingredients in the mix, like Ceph, standardizing scalable block storage, or Kata containers, fast becoming the de facto open source standard for secure container runtimes. And plenty of others, which I don't have time to dive into in this 20-minute talk. That's really what the past decade of open infrastructure looks like. A time for pioneers to take hold in a space that was traditionally held only by proprietary solutions. So what does the next decade of open infrastructure look like? Well, we are seeing early signs that the next decade will see open infrastructure being used everywhere and more and more. OpenStack, for example, is more used than ever. It's easy to lose sight of OpenStack and say, well, this was the technology of before, but actually we've seen more growth in OpenStack usage over the past year than we've seen since the beginning of the project. We've seen 66% growth in the number of CPU cores being driven by OpenStack, up to 25 million CPU cores today. It's also, that growth is actually existing users increasing their footprint. So we have users like Walmart or Line or Yahoo Japan that have crossed the bar of 1 million CPU cores being handled by their OpenStack deployments, or China Mobile, which is one of the big Chinese mobile companies, crossing the line of 6 million CPU cores being handled by OpenStack for their data center deployments in China. But it's not just old users increasing their footprints. It's also lots of new users, new players joining. So what are the trends behind that revival in OpenStack adoption? Well, on the on the open public cloud side, beyond our old partners, the OVH, Deutsche Telekom, City Network, Vexhost, which are all using OpenStack for their public cloud offering, over the past year, we've seen an explosion in new players in the number of public clouds that they provide. More than 100 new public clouds have been created. Those are 5 of them in Binero is in Sweden, Cloudflare in Italy, Infomaniac in Switzerland, Nipa Cloud in Thailand, and Auroch in the US. And this is driven by digital sovereignty requirements or regulations. Countries are really waking up to the fact that it's a vulnerability to handle all of their infrastructure needs to US or China, and that developing a local offering is necessary. In Europe, we have Gaia X defining a framework for sovereign cloud, and there is actually an effort to build a ready-to-use sovereign open infrastructure stack based on OpenStack and Kubernetes called the Sovereign Cloud Stack. So a stack that is compatible with Gaia X but purely powered by open source solutions. The other big trend is niche players pursuing very innovative business models. And that's enabled by permissionless innovation. Open infrastructure allows you to play with the technology and invent new things without having to ask for permission. So for example, we have OneCode, which is a game server cloud located in Guam in the middle of the Pacific Ocean. So you might wonder why they would go there. Well, their business model is to offer equal latency but for Asian and US-based players, so that nobody is advantaged by the location of the server, and they plan to host the big game server, the big game tournaments, e-games, esports tournaments. And so they built this solution sitting on a network node in the middle of the Pacific Ocean using OpenStack and open infrastructure. Closer to home, we have Exion, which is a startup within EDF Group. And they've been recycling old EDF supercalculators that were meant for destruction and installing OpenStack on them and offering innovative services like HPC as a service or blockchain as a service with an eye on the environmental impact of your workloads. And the idea is that it's enabled by the fact that those servers benefit from very fast connections between their nodes, thanks to InfiniBand and other technologies that are only found in very high-end supercomputers. And they built a specific offering based on that. Another innovative use case is Leaf Cloud. It's actually a public cloud distributed over the city of Amsterdam with servers in every building, heating the water that is used to take your shower or heat the building. And it results in an exceptionally green data center footprint compared to traditional data center, because most of the energy used in those servers is actually reused to heat that water. That kind of research and innovation is enabled by open infrastructure, and that's why it matters so much. So we expect the next decade to see more open infrastructure, more open infrastructure projects, like, for example, Magma, which is a new project allowing anyone to build their own mobile network, but also more adoption of open infrastructure for the next decade. And you can be part of this rise of open infrastructure and help defining what the next decade of open infrastructure looks like by joining the Open Infrastructure Foundation at openinfra.dev/join, which is free for individual members. So thank you for your attention. And 7 minutes for question. I just beat my record. Questions? I'm pretty sure Jonathan has questions.
How are you seeing everything? It's about edge computing and so forth. I think you mentioned that at the end, but are you thinking about the impact of open infra in edge computing? And
yeah, so one of the ideas behind renaming the OpenStack Foundation into Open Infrastructure Foundation was to be able to address new use cases under a project and a brand that is completely separate from a very data center centric project like OpenStack. And one of the projects we have is Starling X, which is a an OpenStack plus Kubernetes distribution aimed at the edge and IoT use cases, industrial use cases, but also like far edge deployments. Magma is actually like a very good example of software that is it's software that bridges the gap between the radio access tower and the internet for 5G networks. So it's basically the thing that is highly proprietary in today's networks and extremely costly and requires specific hardware, and they basically built a software solution for that. So I think it's still like at the very beginning of it. We still have to write most of it, but to me it's obvious that open source is the only way to do it, because if you want that edge to become at some point some form of ambient computing, like resources that are really close to you that you can as you travel, you would switch servers, your workloads will follow you around. It will require standards, it will require solutions that are implemented across a number of providers. And I suspect we'll see a wave of proprietary products for some time, but hopefully we'll see open source take its place and hopefully be, because it's way easier to deploy a proprietary data center because it won't go outside of the data center, and it's fine. And at the same time, for edge, it will be everywhere. Potentially in every home, there will be a small box that will contribute to an edge network, and that will have to work across providers. There will be some kind of standard, hopefully an open source one, that will emerge.
Any other question? Okay, maybe one from my side. Is there any official distribution of OpenStack, or are there a lot of distribution made by several companies, like Red Hat, for example, but others are also playing with OpenStack?
So there are multiple OpenStack distributions. The OpenStack project upstream ships releases, and then, but even within the OpenStack community, we have deployment tools. It's a complex stack, so you have to deploy across multiple machines. So usually it takes more than just like traditional packaging for installation on one machine. So various distributions have their own systems. Red Hat has O, which is basically deploying an OpenStack to run the OpenStack above it, like Inception. There is Canonical using Juju charms for deploying across that complex application that is OpenStack across a range of servers. We have a project within the community called Cola Ansible, which uses Ansible to deploy containerized versions of the OpenStack components across fleets of machines as well. They're like community-driven solutions. They're like supported commercial distribution type Red Hat, Canonical, Mirantis has one as well. Multiple solutions for deploying OpenStack, and we're seeing like it's a mix between the two. People are directly using a community-supported deployment frameworks or not proprietary, but
for someone
distribution-supported ones.
For someone who wants to start with OpenStack, what is the best way? Is to take one of Ubuntu or Red Hat distribution?
So Ubuntu has good try-me-out solutions, like they have a micro stack for trying out OpenStack really easily on a single machine. Which would be one of my recommendations. They do the same for Kubernetes, so it's a good way to like install a version of the software and play with it. We also have our own solution called DevStack, which deploys everything on a single machine, but it has to be a very big machine, and it's like community supported. So I would recommend those two to deploy a core set of services on a single machine first.
Okay, thanks a lot.
Thanks everyone.